Srinivasa Ramanujan was one of India's greatest mathematical geniuses, who, despite his difficult beginnings, made numerous contributions towards the field of mathematics. Born in Erode, Tamil Nadu, India in 1887, Srinivasa Ramanujan was born to Komalathammal and K. Srinivasa Iyengar, who was an accountant to a cloth merchant in Kumbakonam. Ramanujan was declared a mathematical prodigy, exhibiting an exceptional understanding of various math subjects at a young age. Throughout his school days, he continuously impressed his classmates and teachers with his exceptional proficiency throughout all branches of mathematics. Despite being considered a mathematical genius, Ramanujan's career began in failure. Ramanujan received a college scholarship in 1904, but quickly lost it due to the fact that he failed several of his non-mathematical subjects. He again attempted to get into a college in Chennai, but once again failed in his first arts exam. It was during this time that Ramanujan began writing his famous notebooks, which contain a total of almost 3,000 theorems. However, in 1910, Ramanujan was interviewed by R. Ramachandra Rao, the secretary of the Indian Mathematical Society. Rao was initially skeptical of Ramanujan, but quickly recognized his talents and financially supported him. Ramanujan departed from Chennai in 1914 to study at Cambridge, UK. At Cambridge, he was mentored by G. H. Hardy, a well-known British mathematician. Later on, Hardy persuaded Ramanujan to share his discoveries with the world. It was 1914 when Ramanujan made one of his greatest discoveries. Finding an accurate approximation of pi has been considered one of the most principal challenges in mathematics. Ramanujan found a formula for an infinite series for pi. Hardy encouraged him to publish his findings, which he entitled Modular Equations and Approximations to Pi, in the 1914 issue of the Quarterly Journal of Pure and Applied Mathematics. It contained not one, but 17 different series that converged rapidly into pi. The formula computes a further 8 decimal places of pi with each term in the series. It was a magnificent equation, considering that it was both accurate and far easier to evaluate compared to the prior formula. This series formed the basis for many key algorithms today, called an invincible originality by G. H. Hardy. Ramanujan additionally is known for his discovery of the Ramanujan number, 1729. Hardy had once remarked about the taxicab number he had ridden in, which happened to be 1729. Hardy had said what a dull number it was, but upon hearing this, Ramanujan had said, "No, it is a very interesting number. It is the smallest number expressible as the sum of 2 cubes in 2 different ways." This exchange would lead to the discovery of more so-called taxicab numbers. Ramanujan also made several other discoveries, including the Mach theta function, the circle method, the theta function, the Ramanujan conjecture, and many more. Ramanujan's discoveries have formed the basis of many algorithms that are used today. He has contributed countless formulas to calculate the digits of pi in many ways that could conventionally not be considered. However, tragedy struck when Ramanujan contracted a fatal illness in England in 1918. He returned to his birthplace in India and spent his last years producing some of his most profound arithmetics. Srinivasa Ramanujan died on April 26, 1920, at the young age of 32. Srinivasa Ramanujan's theories and discoveries continue to flourish and impact modern-day mathematics. His theorems and formula have forever changed number theory and geometry. As Ramanujan once said, "Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding."